This lesson is 1.5, Measuring and Constructing Angles. We're going to be looking at how we measure and how we classify an angle. We're going to be talking about how to look at congruent angles. We'll also introduce angle addition postulate, and then we'll also look at what it looks like to bisect an angle. Okay, and remember the word bisect means cuts in half. So that's what we will be covering. Okay, so when we first look at an angle, one thing to notice is that an angle is made up of two different rays. Okay, so in this angle, we have this ray AC, and we have this ray AB that have this common connecting point at A. This point at A is called our vertex, the common endpoint that they share. And then the sides, of course, we have ray AC and ray AB. We have several different ways that we can name an angle. We can name it by its vertex, which is this common point here of A. So we would call it angle A. We can also use a point on each ray, and so we can call it angle CAB, or we can call it angle BAC. And then also we have times where it'll have a number inside the angle, and so we could call this angle 1. So we obviously have the points that are on the angle, the vertex, which in this case, in this picture drawn here, is A. Then we also have other points on our angle, like D, which is on the side of the angle. But then we look at points that are contained around the angle. So we have points that are inside the interior, so all inside this area. And it could extend beyond what is just drawn, and this would still be the interior. So that, in this case, angle B would be in the interior of our angle. And then we have things that are outside. So obviously all this out here. So in this case, angle, or point C, would be on the exterior of our angle. So to review over types of angles, these are things that you probably are more familiar with, things you've seen previously in math. So we have our acute angles, which is our measure of less than 90. Okay, so this would be an angle that is less than 90 degrees. It's going to be greater than 0. We can't really have a negative angle. Those will come up later, but right now it would be a measure greater than 0 and less than 90. We have our right angle, which means it's equal to 90. We have our obtuse angle, which is greater than 90 and less than 180. And then we have our measures that are equal to 180. So one way we could say this, that if I'm talking about the measure being x, so if I term it as x, then in this case x would be less than 90. Here x would be equal to 90. Here it would need to be greater than and less than 180. So we would need it to be in between. And then we can have x is equal to 180. Okay, so we have our acute angle, we have our right angle, we have our obtuse angle, and then we have our straight angle. So if we look at this example problem, it just tells us that a lighthouse keeper measures the angles formed by the lighthouse at point M in 3 boats. We want to name the 3 angles shown in this diagram. Okay, so this is just talking about naming them. We don't know their measures, we just want to be able to call them. So because they all have this common vertex of M, we can't just say angle M. If I say angle M, it doesn't really tell me which angle I'm talking about. So we can't say that. So instead, we need to call it by 3 points. So the points that are on the sides as well. So one angle we could have would be JML, the big angle going all the way around, which could also be called angle LMJ. Remember, we can switch the letters up. This still talks about the same angle. Notice that when I name it this way, I put the vertex in the middle. Okay, it has to go in the middle, so that way we know that these are on the side, J and L are on the sides, and M is the vertex. So what are some other angles we have? We can look at J, M, and then I could go out, instead of this outside way, I could instead go down the middle and go out to K, which could also, again, I can flip them around and say K, M, J. Then I can have another angle If I start on this other side where I'm going to use L, I could go L, M, K, which again I could reverse this and say K, M, L. Okay, again, another thing to notice is the vertex is in the middle every single time. M in this case was my only vertex, so it's in the middle of all these examples. And then also notice that we have our angle symbol. Okay, and so this is how we shorthand writing an angle. So then we also need to talk about a new postulate that comes up when we have angles. Remember that we had segment addition postulate. So segment addition postulate said if I have this segment that is, say, A, B, C, okay, I have these different segments, that I could do AB plus BC would equal the total length of AC. Okay, so then we have angle addition postulate. It is very similar, but now we're just talking about the measure of angles. And so in this case, we're going to look at the total angle. Instead of having the total segment of AC, we would have this angle going all the way around the outside. Okay, and we can break it up into two little angles. If we have another ray that cuts down the middle somewhere, not necessarily in half, but it does cut it somewhere, then we have these two angles that would add up to make the total angle. And we will have an example to show this again. But this would be our angle postulate. And one thing to notice is how we just mark angles. You can see here that M, the measure of angle RST is this blue line, so it's showing it goes all the way across. Then it has the measure of RSP, and it shows this little red line here. And then it has the measure of PST, which is the green line. Okay, we just draw these little curves inside our angle to be able to denote what angle we are talking about. And then one other thing to notice is that when we would write things like AB in a segment, we would say we want to know what the length is, we would just write it without the segment or the segment symbol above it, and then we could write AB is equal to, say, 5. But when we talk about an angle, we write it as the measure. Okay, this little m means measure. And then we write our angle symbol and the angle that we're talking about. So the measure of RST would be equal to some number. So we're going to go ahead and work an example using angle addition postulate. It tells us that given the angle KLM is a straight angle. Okay, so remember we have straight angles. That means that this is equal to 180. So if we look at KLM going all the way here, it's equal to 180 degrees. Then it asks us to find the measure of KLN and NLM. Okay, so we are looking for these two different angles. We have KLN right here. Okay, so I just put that one in red. And then we have NLM right here. So if I want to find the total, think about angle addition postulate that we just looked at. It tells me that the measure of KLM would be equal to the angles that make up that total angle. So I could do the measure of KLN plus the measure of NLM. Okay, so all I'm doing is adding up my two parts to make my whole again, just like segment addition postulate. So I know that KLM is equal to 180. Okay, because it told me it's a straight angle, so that means it's 180 degrees. Then the measure of KLN, it tells me here is 10x minus 5, plus the measure of NLM, which is 4x plus 3. So then we just use our algebra to solve. So I have 180 is equal to, if I combine my like terms of 10x and 4x, I get 14x. Then I have negative 5 plus 3, which gives me negative 2. So I'm going to continue to solve this. So plus 2 to both sides. I get 182 is equal to 14x. I need to get x by itself, so I'm going to divide by 14. And so when I divide 182 by 14, I'm going to get 13. And then obviously my 14 divided by 14 gives me 1x, so I'm just left with x. But notice it doesn't ask me for x in my question. It asks me for the measure of those angles. So I need to substitute this back in order to find them. So I'm going to get 10 times 13 minus 5. So when I do that, that's going to tell me that the measure of KLN is equal to, so 10 times 13 gives me 130 minus 5 gives me 125 degrees. And then I have, plugging it into this other side, I'm going to get 4 times 13 plus 3. So I'm going to be looking at the measure of NLM is equal to, and that would give me 55. So one thing I can double check is I can plug these back in to my angle addition postulate to show whether or not it would actually work. So going back to this original formula. So if I were to plug that in, I could take away this part, and instead I'm going to plug in my 55 plus my 125. And I know that because KLM was a straight angle, it should equal 180. So sure enough, if I add 125 and 155, it will equal 180, so this does check. So my answers were this measure of KLN is equal to 125, and this measure of NLM is equal to 55. So we have bisecting of angles as well. Again, remember that a bisector cuts something in half. So if we have an angle bisector, we should know that it's going to cut an angle in half. Okay, automatically should be able to think cuts it in. So before we kind of look at this picture some, one thing to notice is instead of tick marks, like we said earlier, angles have these little just curves marked inside of them. If they have the same number inside, then that would mean that they are the same measure. Okay, just like if we have the same number of tick marks, that means the segments are equal. If they have the same number of their little curve inside, then that means they're equal as well. So it says an angle bisector is a ray that divides an angle into two angles that are congruent. So it cuts that angle in half into two congruent angles. So in this figure we have YW bisects angle XYZ. So that way we have XYW would be congruent to ZYW. So we're going to look at an example here where we're going to draw our picture ourselves. So it tells us that QS bisects PQR. So we know we have angle PQR. Okay, our vertex of this angle is going to be Q because it's in the middle. And so that means the sides have those other 2 points of P and R. And it tells us that QS bisects it, so I'm going to be drawing another ray here in the middle. That's going to go out through S. And since it bisects it, I'm going to put 2 little curves inside my angles to show that they are congruent. And it wants us to find the measure of PQR. So the measure of PQR is the total measure going all the way across here. And we're looking for that. We are also told that PQS is 24. So PQS here is 24 degrees. So if PQS is 24, what does that make SQR? Okay, well remember that QS bisected that big angle. So if this one is 24, that means this one would also be 24. So then if we're looking for our total, we would add our parts. So if I want to know the measure of angle PQR, I would simply add up the measure of PQS plus the measure of SQR. Well, we just said both of those are 24, so I can plug in a 24 plus 24, and so it would equal measure of PQR would equal 48 degrees. And that would be my answer. So we're just going to work one more question here with angles. We're going to be looking at a protractor, and we're just going to go ahead and classify them as well. So if we want to find the measure of each angle, let's go ahead and write them out. So I have the measure of angle, and if I want to start just on this left side here, I could do PQ to U. So PQU. Then I could look at this next one, going from UQT. Go to my next angle of TQS. Notice they're all going to have the same letter in the middle. They're all going to have Q because that Q is the same vertex for all of these. So TQS. We can also have the next one of SQR. Measure of angle SQR. Okay, so let's look at these. So PQU, if I start this left side of my protractor, it goes from 0 all the way to about, what, 55 and a half it would almost seem, because it's in between that 55 and 56. So I'm going to estimate this at about 55.5 degrees. UQT ends up going from that 55 and a half to 90. So if I go from 55 and a half to 90, I would need to subtract to find the difference there. So I could do 90 minus 55.5, which would give me 34.5 degrees. Okay, look at my next one of TQS. So that one goes from 90, and I could either look at the top portion of it where it's going higher. I could also look at the bottom. It doesn't matter which way you look at it on this protractor. I'm just going to keep going on this top part. So I have 90 to, looks like 145. So I would do 145 minus 90, which would give me 55. And then I have this last one where I'm going from what would be 145 to 180. So 180 minus 145, which would give me 35. So notice if I were to add all these up, what angle would it give me? Okay, so the total sum of all these would end up going on measure of angle PQR. Okay, because if I wanted to start here at P, go all the way over here to R, it'll be PQR, and that would equal 180 degrees. So if I added these up, you could double check, and they do add up to be 180. Notice that there are other angles that I could be looking at on this as well. Those aren't the only ones. Some other angles I could look for would be like the measure of angle PQT. Okay, I can go from P all the way to T and be looking at that angle. I could do PQS. Okay, I could do PQR, I could do TQR, I could do UQS. There are many different variations. I could choose any of these rays. I could start on one and then go to another ray, and I could make that angle. So if I look at PQT, notice that that angle is 90 degrees. If I look at PQS, that one goes from 0 to 145, so I'm going to do the 145. And so now let's think about classification. Classification was our acute angle, our right angles, our obtuse angles, and our straight angles. So if I want to look for my acute angles, acute is less than 90. So I'm going to write acute over here in red. And I'm going to look at which ones would be acute. So acute would have been PQU here at 55.5. This one also at UQT, TQS, SQR. There could be some more on here from going from probably in between some of these possibly would make acute angles. It would just depend. You'd have to subtract them and see whether or not it would be less than 90. Then I also would want to look for right angles. So right angles I'm going to go ahead and write here in blue. So a right angle, in this case, we did find PQT was a right angle. So remember, you can also denote a right angle by making the little square inside that angle. Then we also want to find obtuse angles. So obtuse is greater than 90, but less than 180. So PQS that we found would be an example of an obtuse angle. And then the last type of angle is a straight angle. Straight angle means it's equal to 180, so that means PQR would be a straight angle. Okay, again, I just ask that if you have questions, you're writing them down, bringing them to class, make sure you're staying on top of things, and then whenever we get to this lesson, be sure you're bringing those questions up. Don't let yourself fall behind.